Hello and welcome to this short video discussing some particle physics and fundamental forces. Well, in this video it's particles only, forces will follow up later. In particular, or as a subtitle, we might discuss and might understand that we're discussing fundamental particles and forces. So this is the general subtopic. This video is only going to cover the particles aspect, and particles is a word you have heard before. This is very common at GCSE. Lots of things we talk about: the particle model of matter, particle model of gases, and it allows us to understand lots of things that we see happening in the world: pressures and forces acting on surfaces, etc. And that brings us straight on to the word forces. We deal with forces a lot at GCSE physics, telling us about accelerations and how things change their motion. But perhaps the focus of this video is this first word, fundamental. Fundamental is what we want to focus on here at A level, because we like to pull things apart. And if I have a box, and if I pull off at one corner, I have a smaller bit of whatever this is. This is something made of matter, and matter stuff is something we're very familiar with, but I think we'll be able to work out a definition of matter by the end of this video, or at least we'll be able to understand quite what we mean when we say matter. So if I have a smaller box, and I might cut a corner off that and I get a smaller box, and I might cut a corner off that and I get something smaller, something smaller, something smaller, smaller. Is there a limit to how far I can pull this object apart? And yes, there is. And that limit leaves me at some fundamental piece of matter. So that is our fundamental part, and that's what we're interested in looking at here. So in science, we know that perhaps more in chemistry than physics at times, we know that we have some object here, something in front of us. If I pull that apart, I might find that it's made of molecules, particular molecules of particular variety. And if I pull these molecules apart, I might find that they are made up of collections of atoms. So I might have an atom. And at GCSE, we kind of stop here and say this is our fundamental building block. But it turns out, experiments over the 20th century, that the atoms can be pulled apart as well. And we notice that at the center of the atom we have a nucleus. And if I pull we've noticed I can pull a nucleus apart and I might end up with a nucleon. And if we keep going, I find that I might end up even with a quark. And we'll just work out what a quark is as we go. And it turns out this is our new limit of fundamental. So at GCSE, we were up here. At A level, we are going to deal with quarks as fundamental objects. And indeed, experimentally and theoretically, this is a very common limit to our understanding. We rarely consider objects smaller than that. So let's put some names to this. Maybe this molecule was CO2. And if I pull the CO2 molecule apart, I might have an oxygen atom. The oxygen atom is made of 8 neutrons and 8 protons. One of those constituents of the nucleus is known as a nucleon. Maybe that's a neutron. And if I pull the neutron apart, I find it's made up of 2 types of quark, and I'm going to call them quark 1 and quark 2 for the time being. We'll work out exactly what they are. And it's important to mention at this point that we never find one quark on its own. There is a concept known as quark confinement, and some lovely, slightly terrifying mathematics will lead you on to concepts of why we never see more than one quark. Sorry, we never see less than 2 quarks. We only ever see quarks in 2s and 3s. But we don't need to worry about that too much at A level. We'll just take it for now that we can't see quarks on their own. Now, at this point here, where I'll split the atom and the nucleus, of course, I could follow a different path and consider instead the electron cloud. And if I pull the electron cloud apart, I end up with an electron. And it is this point here where we have 2 varieties of quark, and the electron are the fundamental constituents of matter. And as I said, this allows us to move from electrons and quarks and say matter is stuff that is made of these quarks and electrons in various combinations. And we'll see quite how powerful that concept is in a moment. So I can state I have quark 1, quark type 2, and the electron. I'll draw them separately for the time being. So I have 2 types of quark and electrons. And electrons are a different class known as leptons. And there are some other pieces to add into that. Notably, the neutrino. And this symbol here is a Greek N, lowercase n, pronounced nu. So nu for neutrino. Looks like a curvy V. Different fonts will draw it in different ways. Let's see how we can make something up from here. If I were to take, say, 1 of that type of quark and 2 of that type of quark, put them together, I might make, so 1 times quark 1, 2 lots of quark 2, I might make a proton. If I take an electron and add that to my proton, I have a hydrogen atom. If I were to take 2 types of quark 1, 2 types of quark 2, and I add to that 2 electrons, then I have 2 protons. I can make 2 protons, 2 neutrons, add the 2 electrons, I have a helium atom. And I can go together picking between some of these, and some of these until I've built up the entire periodic table. Here is the periodic table, quarks and leptons, described in 3 letters. Physics has this power to simplify, to explain, and here we see near on all of the chemical elements described in 3 letters. Now, to go back to our first activity when we were pulling objects apart to find the smallest, let's pull apart our hydrogen. I find it's made of a proton and an electron. The electron is fundamental, I can't pull it apart. The proton I could pull apart into 2 types of one quark and 1 type of another quark. And I can't pull these apart anymore, so I've got the fundamental constituents. And if I do the same thing with helium, I have 2 electrons, 2 protons, 2 neutrons. The protons and neutrons are not fundamental. They can be broken down into a collection of quarks. I've just realized I need 3 of each of those. So I have 6. I'll end up with 6 quarks of 2 different types, 3 of one type, 3 of another, and 2 electrons. But they are the same. This type of quark is the same type of quark. I could swap those quarks around and still build up 1 hydrogen atom, 1 helium atom. These are our fundamental particles as they are broken down. So there's not much more that we want to discuss in this video here, but let's just summarize quickly, and we'll add a little bit more detail perhaps. If I was to take 2 quarks together, remember I can't have 1 quark, that's never seen on its own. 2 quarks will make something called a meson. 3 quarks will make a baryon, the other type of fundamental particle is the lepton, and as discussed, these are made up of electrons and neutrinos. Note that neutrons and protons are a type of baryon. There are lots of different baryons depending on how we mix these quarks together. There's only these leptons that we're going to discuss. There are heavier electrons, muons, tauons, but they're for another day. If I have two quarks together, then I can make a meson, which is something like a baryon. It's a constituent of, it makes something of matter. Lastly, I'd like to point out, as I say, physics is about describing how the world works. The Earth is made up of 3 quark baryons and some electrons. The Sun is made up of 3 quark baryons and some leptons, electrons and neutrinos. You are made up of 3 quarks forming baryons and leptons. All of these things are fundamentally the same. And that is an incredibly powerful and interesting statement to make. You and the Sun are made of the same stuff. There's just different amounts of it, and there's plenty of other physics perhaps we could discuss as to why you don't look like a sun, but ultimately you are very much made of the same stuff. So in the next video we'll discuss the forces instead. Thank you very much.